Did you know your immune system has a secret training academy? It's called the Thymus, and it's where your immune cells learn to fight and who not to fight. Without this small but mighty organ, your body wouldn't know how to distinguish friend from foe. In this video, we'll uncover how the thymus shapes your immune defenses, prevents autoimmunity, and why it's crucial even though it shrinks with age. Hidden behind your breastbone is a small gland with a big responsibility, the thymus. Often overlooked, this organ is a central player in your immune system. But what does it really do? The thymus is the training ground for T cells, a type of white blood cell essential for immunity. These cells originate in your bone marrow, but migrate to the thymus for one vital reason: education. Here, they learn to distinguish between your body's own cells and foreign invaders, like bacteria or viruses. According to a 2021 paper in Nature Reviews Immunology, this education process is so precise that only 2 to 5% of T cells survive. The rest are eliminated to prevent autoimmunity. This is called positive and negative selection, ensuring your immune army fights only enemies, not your own tissues. Interestingly, the thymus is most active during childhood. After puberty, it begins to shrink, a process known as thymic involution, but it never stops working entirely. Without the thymus, your immune system would be chaotic, potentially attacking your own cells. That's why understanding this organ isn't just biology, it's essential to understanding health itself. So how exactly does the thymus train your immune army? Let's break it down step by step. First, immature T cells, called thymocytes, enter the thymus from the bone marrow. They move through to main training phases: positive selection and negative selection. In positive selection, thymocytes are tested on their ability to recognize MHC molecules, complexes on cell surfaces that help identify threats. If a T cell can't recognize these molecules, it's useless and is eliminated. In negative selection, the thymus takes it up a notch. T cells that react too strongly to self-antigens molecules from your own body are destroyed. This prevents autoimmune diseases, where the immune system attacks healthy tissue. The key player in this stage: a gene called IRA, autoimmune regulator. Discovered in the late 1990s, IRA ensures that T cells are exposed to a wide array of self-proteins. If IRA fails, conditions like autoimmune polyendocrine syndrome can result by the end of this rigorous process. Only the most reliable T cells, those that can fight off invaders without harming your body, graduate and enter your bloodstream. Your thymus isn't just an organ, it's your immune system's elite training academy. Ever wonder why kids bounce back from illness faster than adults? The answer might lie in the thymus. This organ is largest and most active during childhood and adolescence. But after puberty, it starts to shrink and fill with fat, a natural process called thymic involution. By the time you're in your 60s, only a small portion of functional thymus tissue may remain. Why does this matter? Because fewer T cells are produced with age, weakening your adaptive immune response. That's one reason why older adults are more vulnerable to infections like COVID-19. As seen in studies published in The Lancet during the pandemic, researchers are now exploring ways to rejuvenate the thymus. In 2019, a small clinical trial known as the TRIIM study, published in Aging Cell, showed promising results. It used growth hormone, metformin, and DHEA to reverse thymic aging, and even partially reversed biological age markers in participants. Could restoring thymus function be a key to extending healthy immunity in aging? Science is still unfolding, but the implications are powerful. The thymus isn't just about producing immune cells, it's about making sure those cells don't attack you. So what happens when thymic training goes wrong? The answer: autoimmune diseases. In a healthy thymus, rogue T cells that might attack your own cells are eliminated. But if this system breaks down, these self-reactive T cells escape into the bloodstream. The result: conditions like type 1 diabetes, multiple sclerosis, or rheumatoid arthritis. Studies published in Frontiers in Immunology highlight the role of thymic epithelial cells in presenting self-antigens to developing T cells. If these cells malfunction, or if the IRI gene is mutated, self-tolerance is compromised. In rare cases, the thymus can even develop tumors called thymus, which are strongly associated with the autoimmune disease myasthenia gravis. In such cases, the immune system mistakenly attacks nerve receptors, causing muscle weakness. This is why the thymus is often removed in certain autoimmune disorders, not because it's causing the disease, but because it may be failing to prevent it. Your thymus is a quality control manager for your immune system. When it fails, your body pays the price. As the thymus shrinks with age, scientists are asking, can we retrain or regenerate it? Emerging research says yes. One approach is thymic regeneration using stem cells or tissue engineering. A 2022 study in Cell Stem Cell showed lab-grown thymus organoids successfully supported T-cell development in mice. This raises hope for transplant therapies in immunocompromised patients. Pharmaceuticals are another frontier. Interleukin-7 IL-7 is a cytokine that helps boost T-cell production. Clinical trials are exploring IL-7 as a therapy for patients with weakened immune systems, including cancer survivors and HIV patients. Then there's gene therapy. Correcting IRA gene mutations or enhancing its function could one day improve self-tolerance in patients prone to autoimmunity. And of course, lifestyle matters too. Chronic stress, poor sleep, and malnutrition can accelerate thymic atrophy. Conversely, regular exercise and a nutrient-rich diet may help preserve thymic function. The thymus may seem like a forgotten organ, but it's at the center of cutting-edge immunology. Understanding it could revolutionize how we treat aging, cancer, and immune disorders.